We are going to talk about higher order derivatives. So what is a higher order derivative? Well, let's let f of x be this function here, this polynomial. Find f double prime of x. Okay, what is f double prime of x? Well, it's the second derivative. It's the derivative of the derivative. Sometimes we call it the second order derivative. So how do we find f double prime of x? Well, it's pretty simple. First of all, we find f prime of x, right? F prime of x is 5x to the fourth plus 21x squared minus 9. So that's the first derivative or the first order derivative. Well, f double prime of x is going to be 20x cubed plus 42x. Okay, so it's just that simple. F double prime of x is just the derivative of the derivative. By the way, if we wanted to find f triple prime of x, we could take the derivative of the derivative of the derivative, and this would be 60x squared plus 42, and you could keep taking derivatives. Now, if this is a polynomial, it'll eventually get to be 0 at some point, but these are called higher order derivatives, f double prime, f triple prime. Now, for the fourth derivative, usually instead of writing 4 primes here, we end up just putting a 4 in parentheses, so the fourth order derivative would be 120x. Now, what is the geometric significance of f double prime of x? Remember, f prime of x had to do with the slope of the tangent line. What about f double prime of x or f triple prime of x? Well, we'll talk about that in a future video. Right now, I just want to focus on taking these derivatives and also on the derivative notation. So as far as derivative notation goes, if we have a function f, its derivative would be f prime. Okay, let's call it f of x. Its derivative would be f prime of x, or we could write df dx. Now, the second derivative, or the second order derivative, is f double prime of x. The way we write this with this notation is d squared f dx squared. Okay, f triple prime of x. And again, sometimes you could write the 3 primes, or you could just put the 3 in parentheses here. This does not mean f to the third power, it just means f triple prime. We'd write this as d cubed f dx cubed. Okay, so the cube comes after the d, but it comes after the x on the bottom here. So let's do some examples. Find d squared y dx squared. So we're using y here instead of f of x. But find, this is really the second order derivative. Another notation for this would be y double prime. So how do we find y double prime? Well, before we can find even y single prime, we need to rewrite this. Let's write this as 7x to the negative fourth plus x to the 9 halves plus e to the 3x. So we just rewrote this 7 over x to the fourth as 7x to the negative fourth. Okay, so now let's find y prime, or dy dx. Well, the derivative of 7x to the negative fourth would be negative 28 x to the negative fifth power. Remember, you have to lower that by 1, and lowering negative 4 by 1 gives you negative 5, not negative 3. Okay, and then plus 9 halves x to the, it would be 7 halves. Okay, if you reduce 9 halves by 1, you're doing 9 halves minus 2 halves, you get 7 halves. Now plus, well, what's the derivative of e to the 3x? Isn't it e to the 3x times 3, or 3 e to the 3x? Okay, we use the chain rule there. So there's the first order derivative. What about d squared y dx squared? Well, to take the derivative of this, we need to multiply negative 5 times negative 28. Well, the negatives will go away. And 5 times 28, I believe, is 140. So we'd have 140, positive 140, x to the negative 6 power, plus, well, we need to multiply 7 halves times 9 halves. That's going to be 63 fourths. X to the, well, we lower this by 1, we're going to get 5 halves. Plus, well, what's the derivative of 3 e to the 3x? Well, it's going to be 3 times the derivative of e to the 3x, but the derivative of e to the 3x is e to the 3x times 3. So we can put the 3 out front here, so we get another 3 is the point. Okay, so we could simplify this and write this as 140 over x to the 6th plus 63 fourths x to the 5 halves power plus 9 e to the 3x. Right, so notice when we took the derivative of e to the 3x, we got 3 e to the 3x. We take another derivative, we're going to get 9 e to the 3x because we get another 3 coming out because of the chain rule. And so this is our final answer. Moving on, here's one where we're going to need to use the chain rule. So what is the second derivative? What is f double prime of x, or d squared f dx squared, for this function? Well, let's take the first derivative. F prime of x is going to be, well, we have something to the fourth power. The derivative of something to the fourth power is going to be 4 times that something to the third power, and then times the derivative of the something. Okay, now let's simplify this and write this as 20 times 5x plus 8 cubed. Now, by the way, can you bring the 20 inside here? No, because we have this to the third power. If this were just to the 1 power, then you could distribute the 20, but you can't distribute the 20. That's just, the algebra doesn't work that way. Okay, well, how do we take the derivative of this? So what's f double prime of x, which, by the way, this is the same thing as d squared f dx squared. Well, what's the derivative of just 20x cubed? Wouldn't it be 60x squared? So the derivative here is going to be 60 times this thing squared, but then times the derivative of that thing. So what this ends up being is, if we combine the 60 times the 5, we get 300 times 5x plus 8 squared. Okay, and that is the second order derivative. All right, and this next one, it's the same thing. We have to rewrite it, though. We have a square root of something, so let's rewrite it as 8x plus 7 to the 1/2 power. How do we take the derivative? Well, y prime is going to be 1/2 times 8x plus 7 to the minus 1/2 power times 8. Right? We have something to the 1/2. The derivative is 1/2 times the something to the minus 1/2 times the derivative of the something. Now let's combine the 1/2 and the 8 here and write this as 4 times 8x plus 7 to the minus 1/2 power. Now that's just the first derivative, the first order derivative, y prime. What's y double prime? Well, y double prime is going to be, well, we have 4 times something to the minus 1/2. To take the derivative, we're going to take the minus 1/2 and bring it down here, multiply it by the 4. So 4 times minus 1/2 would actually be minus 2 times 8x plus 7 to the what power? Well, we have to lower this by 1. If you lower negative 1/2 by 1, you get negative 3/2. But then times the derivative of the 8x plus 7, which is 8. Okay, we could leave our answer like this, but let's combine the 8 and the minus 2 and write this as minus 16 times 8x plus 7 to the negative 3/2 power. And by the way, if you didn't want to have a negative exponent, you could rewrite this as negative 16 over 8x plus 7 to the positive 3/2. And if you didn't want to have a fractional exponent, this is really 8x plus 7 cubed, but then take a square root. Okay, the square root of 8x plus 7 cubed. Or the square root of 8x plus 7 and then cubed. Either order would work. Okay, now this one might seem similar to the other examples here, and you might think, why are we just doing these ones that are so the same? Well, this one's going to be a little different because when we use the chain rule, we're going to end up with an x on the outside. The derivative of this is 2x. Before the derivative was just a constant. So when we take the second derivative, we're actually going to end up having to use the product rule. Okay, so let's see that here. F prime of x is 10 times x squared plus 1 to the 9th power times 2x. Okay, times 2x. Okay, the derivative of this. So let's combine this here. What we really get is 20x times x squared plus 1 to the 9th power. Now, how do we take the derivative of this, right? That was their first order derivative, f prime. What's f double prime? Well, notice we really have a product of two functions, this function and this function. We're going to have to use the product rule. Okay, so the product rule tells us we do the first function, 20x, times the derivative of the second one. Well, what's the derivative of this? It would be 9 times x squared plus 1 to the 8th power times 2x. So all of this right here, that is the derivative of this second part. Okay, so we did the first function times the derivative of the second, plus now the second function, x squared plus 1 raised to the 9th power, times the derivative of the first, and the derivative of 20x is just 20. And you could simplify this if you want. In fact, for this first term here, we have two terms now. We have this term and this term. For the first term, the 20x times the 2x is really 40x squared. Oh, and we also have times 9. So let's not forget the 9. That's really 360x squared times x squared plus 1 to the 8th power plus, and we have 20 times x squared plus 1 to the 9th power. And you actually could even do a little bit more simplifying here. We have both these terms have at least an x squared plus 1 to the 8th power, so you could factor that out. But let's just leave it like this. Okay, how do we do the derivative here? Well, we have a fraction, so we could use the quotient rule. We could do low d high minus high d low all over low squared, and that'd be perfectly fine. In fact, when we do the d high, that would be 0, right? So low d high, well, that's 0. So where that first part is going to be 0 minus the high d low all over low squared. So you could do it using the quotient rule, Or another way to do this would be to rewrite this as negative 2 times 3x plus 14 to the negative 1 power, right? So over 3x plus 14 is like writing 3x plus 14 to the negative 1 power. Okay, and I think when we have the exponents written like this, it's actually a little bit easier when you're doing higher order derivatives. So notice we haven't done any derivatives yet. That's just another way of rewriting y. So we put equals here. Now, I don't want to put equals if I'm going to do y prime. In fact, I want to put y prime equals. Okay, so that's the original y. That equals this. So what's the derivative? Well, if we take negative 1 times negative 2, that's going to be positive 2 times 3x plus 14 to the negative 2 power, right? We lower that by 1, but then times the derivative of the inside function, 3. Okay, so in other words, one way of doing this problem would have been to use the quotient rule, but another way is to use the chain rule here. That's what we use there. Okay, and let's combine these so we can put equals 6 times 3x plus 14 to the negative 2 power. So again, that's just the first derivative. Now what's y double prime, or d squared y dx squared? Well, we bring the minus 2 up front. We get negative 12 times 3x plus 14 to the negative 3. And then we multiply by the derivative of the inside function, right? We're using the chain rule here. Okay, and if you want to, you can simplify this. 3 times minus 12 is minus 36. And in fact, we could put times this, but notice it's a negative exponent, so we could rewrite it as 3x plus 14 in the denominator raised to the third power. Okay, and that should be the same answer that you would get if you use the quotient rule 2 different times. Although in that case, you'd have to do some simplifying your answer to see that it actually simplifies to be this. Okay, what about natural log of x? And here, notice I'm doing y triple prime. So I could have written y prime, 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 but I'm writing the 3 in parentheses here. How do we take the derivative? Well, notice y prime is just going to be 1 over x. Okay, the derivative of natural log of x is just 1 over x. Now, how do we do the derivative of 1 over x? Well, we could use the quotient rule, low d high minus high d low all over low squared, and that would be fine. But let's actually rewrite this as x to the minus 1 power. Okay, so what's the derivative of x to the minus 1? So we're looking at y double prime now. Well, it'd be minus 1 times x to the minus 2 power. Okay, or just minus x to the minus 2. Now, what is y triple prime? Well, we take negative 2 times negative 1. That'd be positive 2, x to the negative 3. Okay, so that's our answer, or we could rewrite this as 2 over x cubed. Okay, so that's the third derivative of natural log of x. Okay, let's do one last example. How do we do the derivative of this one? Well, notice we're going to have to use the product rule because we're taking a product. So and then we're going to have to use the product rule again when we do the second derivative. Now, each time you use the product rule, you end up getting more terms. So we're going to actually have quite a few terms for our final answer here. So what is y prime? Well, it's the first function, x cubed, times the derivative of the second. Well, what's the derivative of e to the 5x? It's e to the 5x times 5, or 5 e to the 5x, plus the second function, e to the 5x, times the derivative of the first, which is just 3x squared. Now, before we take another derivative, let's simplify this. This would be 5x cubed times e to the 5x, plus this is 3x squared times e to the 5x. In fact, you could simplify this a little bit further and factor out the e to the 5x and write it as e to the 5x times this plus this, and that'd be fine. But let's actually just do the second derivative right away here. Now, how do we take the derivative of this? Well, to do the derivative of this part, we're going to have to use the product rule here. And then to do the derivative of this, we're also going to have to use the product rule. So it's going to kind of expand and get a little bit messier here. So let's do the derivative, first of all, of this thing here. So we get the first function, 5x cubed, times the derivative of the second, that'd be e to the 5x times 5, plus the second function, e to the 5x, times the derivative of the first one, which would be 15x squared. So all of this right here, that's the derivative of this. Okay, now what about the derivative of this? Okay, well, let's do the derivative of that part now. We do the first function, 3x squared, times the derivative of the second, e to the 5x times 5, plus the second function, e to the 5x, times the derivative of the first one, which is 6x. So this here, all of this, was the derivative of this second part. So notice our final answer ended up being a big mess. You could simplify it some. In fact, I think all 4 of our terms have an e to the 5x. So you could actually factor out the e to the 5x and write it as e to the 5x times something here. But let's just leave our answer like this. So notice when we use the product rule, we ended up getting 2 terms here. But then when we use the product rule again, this one gave us 2 terms, and this one gave us 2 terms, and so we had a total of 4 terms. If we wanted to find y triple prime, it would get even a little bit messier. So sometimes when you're taking these higher order derivatives, it can get a little bit messy.